Okay. In this session, we are going to discuss about the simulation practical on heat exchanger. So basically, simulation is nothing but a software where we are using to change or to control the different parameters with the help of computer systems, and through the computer system or laptop we can control the actual parameters in the industry. That is the simulation or one of the application of simulation. So there are a variety of simulations available in the market. Now this is one simulation that is called as TSPL, that is Triangle Simulation Private Limited. So this TSPL company made this simulation software for benefits of the chemical engineering students, and this simulation software made from the chemical engineering knowledge and aspects plus C programming. Now in the simulation software there are variety of options available in the demo purpose. So this is the session. So we can continue the session which is actually loaded in the simulation software. We can also go for this design mode, or it is also for cold mode, right? So we can run this software with the help of design mode or with the help of cold mode, or we can modify the different parameters for this heat exchanger, right? So for example, I will go for this cold design initially. So this is the message clearly showing that cold database is loaded, right? Now this alarm system is fluctuating, giving some sound. So we will check what exactly the changes in the parameters. So I'm going to maximize this window, which clearly shows the shell and tube heat exchanger, that is 2-4 shell and tube heat exchanger. So this is the inlet of one of the fluid, and this is the outlet. So this is cold water in, and this is hot water outlet. At the other end, this is the steam or heating media inlet, and this is the outlet for the steam or any heating media. Now we can observe the different parameters like FIC01, TI01, TI04, FI04, TIC01, FI01, FI03, FIC02, TI02, TI03. So all these things are nothing but the controlling devices or indicator devices. So when we are discussing about TI, means it is a temperature indicator only. So it indicates only the temperature of that particular point. Now it indicates 32. So we can click on that 32 also, and we can change the value. We can modify the value. We can also observe what exactly the range of this particular TI01 is. So it is clearly showing that it should be in between the 30 degrees Celsius and 150 degrees Celsius, right? Now it is 32 degrees Celsius. So it is between the range. And in a similar way, you can change the other parameters also. Now what exactly we are going to study in this practical, that if one of the parameter is changed, then what exactly it affects on the other parameters. Suppose I am changing the inlet temperature of the cold water, then how it affects on the cold water outlet or the condensate outlet or the other parameters like flow rate of these two fluids, right? So this is FIC. So it is flow indicator and control. So it indicates as well as control. So how to control this flow rate? So with the help of this valve. So in this on the screen you can consider this valve for controlling device. So this cold water inlet flow rate can be indicated as well as controlled by this FIC01. So likewise, these are the different indicators and controller devices or the instruments which are mounted or works as accessories to the shell and tube heat exchanger. So this part is nothing but the shell, and these blue color tubes are there. That is why it is called as shell and tube heat exchanger. Now there is a partition, that is red color metal partition in the shell and tube heat exchanger, that is on the shell side. So one metal partition clearly indicates two passes on the shell side fluid, and this blue color indicates two metal partitions on the tube side. That is why it is four passes. So you can observe this. So this is the cold water inlet. So these water molecules are going to pass through these tubes. One pass, then reverse direction, second pass, then third direction, third pass, and this is fourth one. So there are four passes. It means these water molecules are passing along the length of this heat exchanger four times. That is why it is called as four passes of this tube side fluid. And this shell side fluid is passes in this direction like this, and it passes along the length of the shell and tube heat exchanger two times. That is why it is called as two times or two passes of shell side, and that is why this shell and tube heat exchanger is called as 2-4 shell and tube heat exchanger, right? So with the help of this simulation, we can control these temperatures as well as flow rate, which are controlling parameters. So we can control the inlet temperature of this cold water, we can control the flow rate of the cold water, as well as we can control the temperature and flow rate of this steam inlet or the media or heating media. But we can't control the hot water outlet or the condensate outlet. But we can observe what exactly the changes occurred after changing the inlet parameters of this cold water or the steam. So with the help of this simulation software, with the help of this computer system, we can easily observe, compare, and control the different parameters which is actually running in the industry. So in this session, now this is the cold version. In the same way, we can run the other sessions. Now I am going to initialize the design load. Now this is the design database loaded message. Okay. Now you can observe this change. Now this TI04 in initial cold design, it was 32. Now it is 96.96. And accordingly, other parameters are also changed. Now this TI01 is 114. FIC01 is 3087. This FI04 is 2570. TIC01 is 114. FI01 is 3715. FI03 is 1145. FIC02 is 3715. TI02 is 165. And TI03 is 77.32. So the as per requirement and as per our application, we can change the parameters, and accordingly we can observe the effects on the other parameters. So we can also control these parameters manually or with the automation. So just click on this TI01 value 114. Now you can observe this range of this value, that is from 30 to 150, right? So now currently this showing as 114. In the previous cold version it was 32. Now it is 114, but it is in the range, right? So in the same way you can observe the other parameters also. If you want to observe these parameters with respect to the set point, whether all these parameters or the values are within the range or not, you can just click on this alarm system. So I'm going to click on this, and you can observe these alarm system values. You can also observe the parameters or values with the help of bar graph. So this is the bar graph clearly showing the different values, that is set point, the actual values, operating values, and if there is any alarm systems for that particular value. You can also check these values with the help of trend, that is whether it is in the upper range and lower range values. So U range means upper range. If it is the green color line, then it is showing between the lower range 0 and upper range 9,000. But what exactly this green color is? So this green color is nothing but FIC01 value. That is flow rate indicator and controller of 01 value. So it is ranging from 0 to 9,000, and currently the value of FIC01 is 3087, right? In a similar way, that is for FIC02, which is indicated by sky blue color, TIC01, which is indicated by the yellow color. So all these range and actual values or current values are given in this table, and you can track this record on this trend also. So now you can observe on the screen the sky blue color, yellow color and green color line is showing. So this record is of some seconds. Now you can observe these things for minutes or hours also. You can save these trend analysis. You can print this, and you can also mail all these analysis for 8 hours, 16 hours or for months also. So that is depends on your requirement. Then this is the basic value. Now I am going to change these values as a run. So I am going to change this run now. Now you can observe the changes in the different parameters, right? Now in the previous design mode, it was 96.96 as a TI04 value. Now it is 8792.5. Now it is changing, and that is the change up till the set point value is reached. So we can change or we can observe these different values. Now TI01 is 70, FIC01 is 3085, and likewise all these parameters are changing now. So depending on our requirement, depending on the set point, all these parameters are changing and they are trying to achieve the set point. So all these parameters or the values are within the range or not, which is indicated in the alarm systems. So this is the alarm systems which is showing that two values are not in the range. So which are these values? FI03, that is flow indicator 03. The value should be within the 1000 and 4000, but now the current value is 762. That is why this alarm system or alarm summary is showing that this value is below the range or beyond the range. The second parameter is TI03. So the range is between the 44 and 86, but now the current value is 93. So it second parameter exceeds the value, and first parameter is the lowest value below the lower range. So this way we can change the observations, or we can check all these parameters. We can manually or automatically check these parameters, and according to our requirement, we can check also these bar graph values. We can check these trends, that is current trend. We can print out these different trends, graphs, the alarm systems, etc. And if you want to study or learn the different terminologies which are involved in this simulation software, then you can go through the help menu, and with the help of this help contents, you can learn a lot regarding these heat exchangers, right? So this is a basic idea regarding the simulation software. Now you can also observe the shell and tube heat exchanger parameters on a continuous basis with the help of this animated interface. So this animated interface gives you the exact idea how the water is going to flow like this. This is the water inlet, one pass, second pass, third pass, and fourth pass. And this is the heating media. That may be a steam, how it is passes. So like this is going to pass, and this is the outlet of this condensate or any heating media, right? So this outlet of this heat exchanger is going to use for this distillation column. So this is attached to this distillation column. So all these values can be observed, can be noted down, and can be changed manually or with the help of automatic option. Okay, I hope you have the idea regarding this simulation software that is designed by the Triangle Simulation Private Limited company for the heat exchanger. Thank you.